Hello everyone, welcome to our day one of our distributor spring training. Today we're going to be talking about microchannel. If you have any questions throughout today's presentation, please submit those and we'll get to those questions at the end. So let's jump in. Nortec implements microchannel technology on our following product lines: air handlers, evaporator coils, AC condensers, heat pumps, and our package equipment. When we went from copper tube and fin coils to our current microchannel aluminum coil, one reason was because of formicary corrosion. We see formicary corrosion most commonly with household chemicals and tight construction of modern homes. 90% of formicary corrosion leaks are caused by organic acids, and these acids would be in the airstream of the HVAC system. Our microchannel coils have aluminum extruded tubes. We found that with microchannel coils, they're very resilient to high corrosive environments. Also too, that microchannels have a good heat transfer. So when you've got a evap coil, you're going to dehumidify the space very well, and then you'll also have better heat transfer when it comes to heat pumps during your fall and your winter season. Microchannels are also smaller, lighter, and stronger units. And we also offer a aluminum braze kit, which is part number 922023. With microchannel, you may achieve a higher SEER value than what's stated on the equipment. For example, if you use a straight AC 14 SEER and you pair that with a variable speed furnace with a TXV on the coil, you can achieve up to 15 SEER for that pair of equipment. Also too, many of our package unit models have microchannel evaporators and condenser coils. The install procedure for a microchannel is going to be the same as tube and fin. A lot of times guys think that they need to do all these extra steps and take all these precautions when it comes to microchannel. And really what you want to do is just use the same principles when you're installing a tube and fin system to a microchannel system. The only thing that's going to be really different is that microchannel in itself just uses less refrigerant. Now what I have here are two pictures of microchannel coils. The picture on the right here is, I just wanted to point out just the refrigerant flow through a microchannel coil. Also too, we have a picture of a cutaway from a microchannel coil, and when we take a look inside here, we have our parallel tubes, and then each parallel tube, we have little sections in each of the parallel tubes. Now, when it comes to installing the microchannel, this is why in tech we really stress to use nitrogen when brazing, because what you don't want is that corrosive material to flake off once you release the refrigerant and potentially clog up a microchannel coil. Just speaking from tech, it's pretty rare that this happens, but you really want to take that practice when it comes to brazing and installing microchannel. All of our C7 and C8 series coils and our RPL coils that have a letter M at the end of it are all going to be microchannel. Many of our B6 series air handlers are also microchannel. The only air handler that is not microchannel is going to be our B6 VMAX air handler, and this is generally going to be paired with our inverter driven heat pump on our BG line, our 18 SEER heat pump. But everything else that we have on our B6 line is going to be microchannel coils. The benefits for microchannel on our coils is that you're going to have a superior corrosion resistance, so that's going back to the formicary corrosion. Microchannel in itself is going to be about half the weight of a traditional tube and fin coil. So when you're moving equipment, installing the equipment, it's going to be a lot easier to, one, install that, and if you have to get that equipment up to an attic, that's going to be a lot easier to do that. Also too, you're going to have less pressure drop, and the evap coil can dehumidify really well because we have a greater surface area when it comes to microchannel coils versus a traditional tube and fin type coil. Now, a very common thing that we do get questions on in tech service is how do we clean microchannel coils? What you really want to use is just water and a hand soap type of cleaner. You really don't want to use any type of chemical, because if you don't get all of that cleaning chemical off the coil, you'll end up eroding that aluminum coil, and that won't be a good thing. So what you really want to do is just use hand soap and water when it comes to cleaning microchannel coils. The next thing that we're going to talk about is where do we find matchups when it comes to our equipment. The main three areas that you can find matchups on is going to be in our tech specs, our Qrd document, and AHRI is another resource you guys can use when checking for matchups. Now, the technical specifications along with the Qrd can be found on our literature library. All of our condensers will have a Qrd sheet that comes with it, and that'll tell you what the matchups are for that particular condenser. And if you need to make either a TXV change or a piston change, it'll be in that Qrd document. When it comes to troubleshooting microchannel coils, what you don't want to forget is the airflow part of your heating and cooling system. So if you have guys that are coming into your distributor seeking advice and help when it comes to troubleshooting, some things you want to point out are, what does the return filter look like? Because we may need to change out the return air filter. The other thing is you want to take a look at how clean is your evaporator coil. You may also want to suggest measuring your static pressure, because that'll help prove if we have an airflow problem. Then we can calculate CFM if needed. You also want to verify airflow per the air handler or furnace install instructions and make adjustments as needed. So in the install instructions of the equipment, or if we're working on one of our newer pieces of equipment, we have a blower document that shows CFM along with static pressures of that given equipment. So if you take a duct static pressure, you can then look at the blower chart and see what your CFM output is per the blower chart. So we don't want to forget about airflow when we come to troubleshooting microchannel coils. When it comes to charging microchannel condensers, what you want to be doing is just adding a couple of ounces of refrigerant at a time. If you take the traditional route with a tube and fin type of equipment, most guys are adding in about a pound at a time, or maybe a half a pound. But when it comes to microchannel, as a whole, microchannel again uses less refrigerant. So if you go the route of the traditional when adding refrigerant, you most likely are going to overcharge the equipment. So you want to just add a couple of ounces at a time, let the refrigerant cycle through the system, and then retake your readings for your pressure and your line temperatures and see where you're at on your charge level. When it comes to preventive maintenance, use gauges with short hoses to check the charge. So again, with microchannel using less refrigerant, if you use really long hoses, you're going to be taking more refrigerant out of the system if you have longer hoses versus shorter hoses. A restriction could trip the high pressure switch even if the restriction is a stuck closed TXV on the indoor coil. Now, this is going to be a common call that we get into tech service through spring startup and along during our summer season. So what ends up happening with microchannel in a restriction, if you have a restriction at the TXV or if you have a piston that's gummed up, basically what you'll end up doing is stacking refrigerant on your liquid line, and then you'll end up filling up your condenser with refrigerant, and eventually that system's going to go off on high head pressure. Now let's talk about if we have an evaporator that is starved of refrigerant. This is another common call that we do get into tech service when it comes to evap coils that are dripping water off them. Now, when it comes to our microchannel evaporator coils, the distributor tube is going to be this tube down here. Now, if you're more familiar with a traditional copper tube and fin type coil where you have a TXV, say, right here in the middle, and then you have distributor tubes that go out feeding the coil, when it comes to our evap coils, the refrigerant's going to come in on your liquid line. It's then going to hit your metering device, which on this picture is a piston, and then it's going to fill up this bottom tube here. What's then going to happen is that the refrigerant is going to fill up this evaporator coil, go up over the apex, and then back down on the other side of the coil. Now, some questions that we do get into tech is the right side of the coil is colder than the left side, which that's okay, that's normal. because as far as your refrigerant boiling off, at whatever point that is in your evap coil, your right side of the coil is just inherently going to run colder. Also too, when it comes to potentially dripping water off an evap coil, that mainly gets down to airflow or a charge related problem. Most of the time what we find is that in relation to airflow, the blower speed is just set too high, where you have a superheat number that's off. Or when it comes to charge, you may have your metering device that's not feeding your evaporator coil enough refrigerant. So what ends up happening is that most of the calls that we take is that we'll end up dripping water off the left side of the coil. And what's happening is that if you're starving your evaporator coil with refrigerant, your boiling point may be over here versus say over here on your coil. And what'll end up happening is that you'll develop dry spots on the coil, and then when the water channels down the coil, if it hits a dry spot, it's just going to drip right down instead of channeling down the coil as it should to your drain pan. So that's the main thing when it comes to how does the refrigerant flow through an evaporator coil. And again, I just tell guys it basically fills up like a glass of water, and then it goes over the apex and back down to your suction side of your system. Now, this can also happen with fin and tube type coils. Many guys think this is just a consequence of a microchannel evaporator coil, but this can also happen if you underfeed a tube and fin coil, whether or not you have a bad TXV or you have a piston that's underfeeding that coil. After checking the charge and verifying the superheat, along with verifying proper airflow, if a microchannel coil still drips water, we have drip baffles available to you guys. And these are the part numbers for your A and your B width cabinets, and then this is the part number for your C and your D width cabinets. The next thing we're going to go over is how do we get to our literature library. And really there's two ways that you can access our library. The first is that you can go to our homepage, which is nortechhvac.com, and on our homepage we have a technical literature tab in the top right corner of the screen. Or what you can use is the QR reader code that would come on the equipment. If you have an Apple iPhone, you can just use your camera app, or if you have an Android device, you may have to download a QR reader code. But those are two ways to access our literature library. And on our literature library, what we have for you guys is a variety of different documents, and you don't need a login or anything like that in order to get into our literature library. But what we have available to you guys for the equipment that we make are tech specs, the Qrd documents, install instructions, parts lists, wiring diagrams, supplemental charging info, and then we also throw in some consumer materials for you guys as well. When talking about the Qrd document, some things that we're going to cover are how do we determine a matchup on the Qrd document, and if we need to change either a piston or a TXV per your system matchup. This document is going to include condenser matchups, orifice sizing, and system charging information. When it comes to looking at your particular matchup, some questions that we get are, what if in my matchup box that I have a bolded text, or if the box is shaded gray? So let's take a look. If I have a bolded text in my box, for example, that's going to mean that the indoor metering device is going to change. Now, most of the time this happens on our piston-driven systems where we may need to change the piston, but you also may need to add a TXV for your particular matchup. Now, if you have a shaded box, that's going to tell you that the outdoor metering device changes. Now, this really only applies to our heat pumps that are driven by pistons versus the TXVs on our 16-SEER two-stage equipment. But a shaded box is going to tell you again that the outdoor piston has to change. Now, a lot of guys ask is, okay, if I have to change the outdoor piston, where do I find this information? You'll find a table on the last page of our Qrd document that's going to be labeled Outdoor Restrictor Changes. Now, this table is going to tell you your outdoor piston changes for your particular matchup. So what we have here is our outdoor equipment, our indoor equipment, We then tell you what the factory installed restrictor was on that outdoor condenser, and then we put in what the restrictor needs to be per your matchup. So again, this is something that you don't want to forget if you have a shaded box for your matchup on your Qrd document, because this will help you when it comes to either checking charge in the fall and winter time, and you don't want to have to go back, pull the refrigerant out, and then change your piston on that system. So don't forget about this information when it comes to if you have to change out your outdoor piston. Now, when it comes to line set sizing, we do get questions in tech on this as well. So the main thing is that we do get is that if we have a contractor that's got a line set that's, say, in a drywalled ceiling, or say in an apartment complex or a condo complex where the line set is buried in a wall or a ceiling, and they want to know if can I use this existing line set. What we do have available to you guys is a long line set guide, and we do have in there different line set sizing along with your overall length of your line set and your percentage loss for your particular line set that you have. So we have data all the way up to 175 feet of line set, and then we also have other information in there as well when it comes to vertical lift on a line set, for example. But those are some questions that can be answered just by looking at our long line set guide. Now, if you're going to reuse an existing line set, what you want to do is make sure you flush out that line set if you're going from, especially from R22 over to 410A. So you can just use like RX11 flush, which is perfectly fine when flushing out that line set, but you just want to make sure that that line set is clean before you drop 410A on that line set. If the existing line set cannot be properly cleaned, replace that line set. So basically what our view is that if you're, say, switching refrigerants and you have access to that line set, you want to replace that line set just to make sure you don't have any future problems either with the compressor or with the refrigerants not mixing with each other, and just save you a lot of headache down the road. So if you can replace the line set, replace it, but if you can't, flush it out and make sure it's clean and clear on that. When brazing the equipment in, or if you're doing overall repairs on your system, you want to make sure that you use nitrogen when you braze. Now, what I have here is a picture of a copper pipe that used nitrogen while brazing versus a pipe that didn't use nitrogen while brazing. So you can obviously tell a difference between the two. Another thing that I want to point out is that once you start to charge the system and you have refrigerant flowing through these copper pipes, 410A is going to act as a cleaning agent and can cause this soot to flake off into your system and gum up either your TXV screen or your piston screen and cause a restriction in your system, which can cause a huge headache, especially on a new install when it comes to installing the equipment and commissioning the equipment. When it comes to repairing microchannel coils, we do have a repair kit available to you guys. Now, there's four main things that you're going to need when repairing a microchannel coil. You'll need a low heat torch, solder, a wire brush, and needle nose pliers. Now, per our picture here, it looks like on our coil we had a leak about in this region on this channel. Basically, what you'll end up doing is just taking your needle nose pliers, you're going to pull these fins out on the bottom and the top portion of the coil channel. And then what you'll do is take a wire brush, clean up that area a little bit, and then apply your solder. Again, you want to use a low heat torch, so you don't want to use a turbo torch or an oxyacetylene torch because you'll end up just melting the aluminum coil. One question that we often get into tech service is that can we pump down a microchannel condenser? We try to steer you guys away from doing this because we end up hurting the compressor on the condenser. Now, when you're talking traditional tube and fin type equipment, generally you'll pump the system down to about 20 psig. On microchannel condensers though, the compressor may go into an internal bypass if you try to pump down that unit. Also, what you have to keep in mind is that if you have a longer line set, you may not be able to get all that refrigerant back into the condenser anyways, which will then prompt you to remove refrigerant. So refrigerant will need to be recovered. Microchannel coils require much less refrigerant, and recovering clean refrigerant into a clean tank, you then can put that refrigerant back in if needed. So a lot of time guys think that if you remove refrigerant from a system, you then have to weigh in brand new refrigerant. If you know you have a clean tank, you can weigh that refrigerant back in so you don't have to charge the customer for refrigerant. Scroll compressors contain an internal pressure relief safety that will open to protect the compressor motor windings. Forcing a scroll compressor to pump down to deep levels can be damaging. Doing so will not save sufficient time in the field. Recover the system charge when repairs downstream of the condenser section are necessary. So again, this just goes right back to, it's going to be a lot quicker for you guys to just pull the refrigerant out of the system, do your repair, pull a vacuum, and then recharge the equipment versus trying to pump the system down and then taking out the refrigerant that wasn't able to be pumped down into the condenser, and then trying to figure out what your charge is after you get your repair complete. So just pull the refrigerant, and it's going to be a lot easier on the back end when it comes to recharging the equipment. Again, there's many benefits to using microchannel equipment. The microchannels themselves are going to be very durable. They weigh up to 40% less than a standard tube and fin type coil. They use about 50% less refrigerant than a standard coil. They have more surface area and therefore will be more efficient. And also too, they're going to dehumidify a space a lot better than a traditional type tube and fin coil. So you'll have a greater surface area and better heat transfer with microchannel equipment. So with that, let's take a look at your questions that I've been filling in over our training, and we'll try to get to them all today. Let's take a look. Okay, so first question relates to troubleshooting a restriction in microchannel. So basically, when you're troubleshooting a restriction in microchannel versus a tube and fin, it's really not going to change. So you still want to be looking at line temperatures. You still want to be taking your temperatures across your filter dryer. As a whole, it really doesn't change when you're transitioning from a tube and fin type of system pair to a microchannel pair of equipment. One thing that you really want to do is make sure you use a thermocouple type thermistor when doing your line temperatures, that you want to tell your contractors that. So versus a laser, because it makes it a way faster, a lot easier, and a lot more accurate when you're troubleshooting with a thermistor versus a laser. So with that, just a couple of points when looking for a restriction. I always tell guys that your liquid line temperature, mind you, this would be in cooling mode coming up, your liquid line temperature always has to be ambient temperature or above. That's going to be all the way to the indoor coil. So if your tech is out there on the job site trying to figure out where the refrigerant's at, if he takes an outdoor liquid line temperature at the condenser, it should be at least ambient or above. And then I usually have a guy go in and do the same thing right before it goes in the coil, and it should be the exact same temperature. If it is, your liquid line's good for a restriction. So that's a little bit kind of insight as far as what we tell guys on the phone to do when looking for restrictions. Another thing that I'll point out to you guys that you may get questions on from the field is there are strainer screens that are before the pistons on that. So if you have a guy go out and pull the charge, check the piston for an obstruction, don't forget to tell them that there is a strainer screen before that piston. So that applies to the Evap coils. It applies to the little distributor. We call it a swivel nut connector, like on our 14 SEER equipment. For example, there is going to be a strainer screen on the line set side of that piston. So Don't forget to check that too, because your piston may look clean, but you may have a bunch of garbage that's in the screen plugging it up for a restriction. So yeah, that's a little insight as far as how we kind of tell guys to approach it, a restriction. In the field, don't overcomplicate it. It's the same thing as a regular tube and fin type of system. Basically, I try to just break it down as a refrigerant flow related problem, and just kind of work with either the pressures that the tech has given me or the line temperatures as well. So, but yeah, just a little bit insight on restrictions. Another question, just kind of going right into that. Are the pistons that we use directional? The question is, or the answer is yes. So basically the type of pistons that we use are going to be bullet style pistons. And the bullet style, or the round portion of the piston, would want to point toward the evaporator coil. So on a indoor A coil, for example, I basically tell guys it's like if the bullet is traveling down the line and going to your coil. So yes, they are directional. Make sure they're, if you happen to take one out, if you're looking for a restriction or changing out a piston on a new startup for your matchup, just make sure, one, you put the piston in the correct way, or we're going to have a bunch of problems. So also too, on the piston on the outdoor unit, in heat pump mode, that's when that piston is activated for a heat pump, like a 14 SEER. On the 16 SEER 2-stage, it's a TXV out there, but on the 14 SEER, it's a piston-driven outdoor unit. So you want to make sure that the piston is pointing toward the condenser unit, because that would be your evaporator coil in heat pump mode on that. Another question here revolving around just the filter dryer and the placement of it. So this kind of changes a little bit per your application a little bit. So normally what we tell guys is that you want to install the filter dryer on the inside closest to your evaporator coil. So this would be definitely true when installing an air conditioner. Just a couple quick points on why we tell guys to do that. One thing is that it keeps the outside whip and the line set a little more tidy, looks more aesthetically pleasing outside versus having a big old filter dryer out there. Also too, really the main reason is that you'll catch all the contaminants before they enter the evaporator coil. And then also too, that filter dryer won't rust on you. So if you can keep it out of the elements, you'll basically eliminate a potential leak point at some given point in time when the filter dryer were to rust and potentially have a hole in it. But mainly the tech side portion of it is that you'll be able to catch all the contaminants before they enter the evaporator coil. I know that's a lot easier said than done sometimes, because on attic installs you got to drag your torch up there, which you would have to anyways to brazen your line set, but you know, that's just an extra thing you guys would have to worry about. Now when it comes to heat pumps though, basically what we tell guys is that you want to install it on wherever your evaporator coil is. So let's say you're doing an install and it's late fall, or maybe it's in the winter time, and you have a heat pump. You'll obviously be utilizing that heat pump in that heating season. Your outdoor coil is now going to be your evaporator coil. So at that point, what we would tell guys to do is to place the filter dryer on the outside, so that would catch anything potentially from an install, any trash that may have gotten in the line or anything that might have flaked off when brazing. It'll catch that before it goes into the outdoor coil, and prevent any potential problems that you may have, because again, that is going to be your evap coil in heat pump mode. So just a reminder on that one. Great questions, guys. Again, if you guys have any questions revolving microchannel, just microchannel in itself, or stuff when it comes to troubleshooting microchannel, just feel free to submit away on that. Another question here is, do we use gaskets on our threaded connections? So basically what you'd want to tell your contractors out in the field is that we do not use gaskets on our threaded connections. So that applies to the brass connections on the evap coils, along with the swivel nut connector that would be found on the outdoor unit. So essentially what it is, it's a brass to brass connection, and then it's the threads that make the seal. So you're not actually going to use any type of thread, gasket, or Teflon is another question that we get, is do you use Teflon on your stuff? No, it's just brass to brass. The same thing would be applied to installing a TXV. On the threaded TXVs, it's just going to be a brass to brass fitting. Same thing on our mini split applications. It's a threaded connection. What you guys can do, and it's really a good practice to do this, is to use either a drop of refrigerant oil, which is best, or what you can use is a product called Nylog. And basically all you're doing is just making sure that the thread's made up well, because again, that's what's going to create your seal. And it helps the overall connection on brass threaded connections. So if you were to put anything on that in regards to trying to seal the connection, if you will, use Nylog or refrigerant oil. We really try to steer you guys away from using anything that's like leak lock or anything like that, because most of that stuff is not refrigerant compatible. So if you were to get that in your refrigerant system, it's not going to be a very good day. So, so yeah, steer away from that stuff. Just use Nylog or refrigerant oil. Okay, yeah, a lot of great questions, guys. So another question, when it comes to cleaning microchannels, the best thing that you want to do, the most ideal thing, is to really use just water if you can get away with it. I know like some situations and some environments may require a little more elbow grease, but you really want to use just water. And if you were to use a soap type of cleaner, you really want it to be the equivalent to hand soap. The main reason why we stress this to you guys at the distributor, along with the contractors that call in on this question, is because if you don't dilute, say, coil cleaner enough, that's just going to eat away at the microchannel fins. It's going to eat away at the aluminum. It's not so much that it's a microchannel problem, because there are other manufacturers that use aluminum coils. It's mainly just the high corrosive potential acid content that would be in those cleaners, that if you don't do a thorough rinse, you can do yourself some harm later down the line, as far as potential pinhole leaks and stuff like that. So if you can, just use just soapy water, garden hose when doing an outdoor coil. When doing an indoor coil, I've used like a paintbrush, for example, a stiffer paintbrush to get in there. You may have to use a little more stiffer, like metal brush, wire brush to get, whatever you're working on. But really what you want to use is try to use water only, and then if you have to, use a coil cleaner, make sure you dilute that way down and do a thorough rinse and make sure all that's off the coil, just so you don't have any potential problems that may come up in the future on that. A lot of great, good questions here, guys. I will point out that the training from today and tomorrow that we'll be doing should be available on our EdgeTech training website. We'll also most likely post this to YouTube as well. Days 1 and 2 that we did for the contractor side are posted on YouTube. I would assume that this is also going to be posted on our YouTube channel. So if you want to go back and review that presentation or show this to your contractors, that would be a way that you guys can present that, or at least tell your contractors in the field, hey, this is what we went over. So you can either point them to the YouTube channel or you can point them over to our EdgeTech site. I would assume this would be up a relatively short time, so the other 2 videos were up pretty quick. So. But yeah, so these will be posted somewhere, either on our YouTube or on our EdgeTech channel, and for later viewing. Again, guys, if you have any other questions revolving around the presentation that we did today, just feel free to submit those. Really what I try to stress to contractors and even new distributors that have come on board with us, when they're switching over from a tube and fin type of equipment to a microchannel, the practices that you use when troubleshooting, when installing the equipment, really don't change. Basically, all that microchannel is in itself is using less refrigerant. You're still going to be using superheat and subcooling to check your charge. You know, the coils, like I said, they still have to be cleaned, just like regular tube and fin type coils. You know, you'll still take your line temperatures the same way like you would any other unit. So all of that troubleshooting is going to be exactly the same. As far as installation practices, really none of that should differ from anything else. The biggest thing that we stress into tech service or from tech is to use nitrogen when brazing, you know, just to prevent all that soot buildup that would be on the inside of the copper line, because once 410A rushes through there, some of that stuff can flake off and get into your metering devices, cause restrictions, stuff like that. So really it's just using less refrigerant overall when it comes to microchannel. So with that, guys, what I'll do here is I'll wrap it up here. So I want to just say thanks for tuning in today. Hopefully what we had gone over in our presentation was beneficial to you. At least just getting more familiar with Microchannel on the new distributors that have come on board with us. And if you have any questions revolving around Microchannel that you may have think of later, feel free to call into tech and we can answer those for you. But like I said, hopefully this was just more of an insight on what Microchannel is and how that applies to Nortech and our equipment. Tomorrow what we're going to be going over is contractor tools, so it'll be really similar as far as the format. I'll do like a presentation in the beginning and then we'll have a Q&A session. So Tomorrow we'll be looking at, say, like our literature library. We're going to go over the charge calculator a little bit. Just want to make sure that you guys are familiar and you know where to pull information when you have customers come in looking for certain things. So that's what we're going to cover tomorrow, and then we'll answer your questions at the end. So again, thanks guys for tuning in today, and have a good rest of your day.